So $70 is the price and 20% is the discount.
How much you have to pay? That's the question. Okay. Yep.
I got $14 discount.
So how much you have to pay?
Huh?
How much you have to pay? Okay. Here comes Yaganya. Hello Yaganya. How are you, beta?
I think you have to pay $56 for it.
$56. Hello Yaganya. Can you hear me okay? Welcome back to the class. So Yaganya has been part of the class for quite some time. She took a break and she's back. Welcome back, beta.
Thank you.
Okay. Okay, how about, so we are going to talk about exponents today, that's the plan. But in the previous class, we talked about percentage. Before we move on to the next topic, I want to see how comfortable you guys are with percentage concepts. That's why I'm not rushing for it. I'm just trying to make sure that everybody is able to catch up real quick before we move on. So let me check where is my kids are. And let me see where is Manas and Kian. Okay. All right. So Yaganya, a quick question I was asking the kids was that I'm just checking on your comfort with respect to percentage calculation, okay? Yep. Hello, Naita. Yep. I missed your name. So there's a question here on the board. I'm saying that now we are approaching Thanksgiving, right? So there'll be a lot of discount offered by different stores.
I can't see your screen, sir.
You're not able to see my screen? No.
No.
Okay.
It's like gray.
Sorry, say that again.
It looks like plain gray. I don't see.
Okay, so disconnect and join. That's the trick. I've seen that whenever kids are not able to see it, they have to disconnect and join back again. Yeah. Anahita, can you see the screen okay?
Yes, sir.
Okay. So I'm just checking on the percentage, knowledge of percentage, okay, for all of you. So we talked about percentage in the last class. So I'm checking how comfortable you guys are. I'm saying that during Thanksgiving, can you see it now, beta? Yaganya? Can you see it now? Yaganya, are you able to see the screen now? Okay. Okay. So the question here is that during Thanksgiving, you went to a store. Store says there's a 20% discount on anything and everything that you pick up. Okay? So you picked up a shoe which is priced at $70. So with 20% discount, how much you have to pay? Can you guys try calculating that real quick? Yeah, Vivan has already told the answer, so I know it. Ashrita, Anahita, and Jaganya. Are you guys able to do it, or you would want me to? Okay. Tell me, Ashrita, what is your answer, beta?
I also got 50 cents.
Okay. Anahita, how about you? Anahita is upset with me because I did not mention her name in the message. I said waiting for Kian and Kian and Manas. That's what I mentioned. Okay. Okay. All right. So, jokes apart. How about you, Yaganya? Have you practiced this before or something new? Don't worry about it. So, take it easy. Anahita, do you recall what we learned in the previous class? And are you able to calculate this? Anahita is angry with me, not talking to me at all. You're still dealing with allergy that you had in the last class. Okay, so coming back to this one. Percentage. Okay. Now, let me give you guys some. Hey Manas. Everybody keep your videos on. I love seeing the kids. It's okay. Don't hide behind the screen. Okay, so here. Yeah, Naita, go ahead.
Sir, I'm trying to figure out, there's like a problem with my computer. I'm trying to figure out like...
Don't spend the time. Okay, don't spend time and energy on that one. There's a technical problem. No need to struggle with that. As long as you can hear me and you can see me, okay, it's fine. Okay?
Okay.
And as long as I can hear you, that is also fine. Okay? Hi, Sami. So, I'm checking on. So, my request to all the kids is keep your videos on. That way, it'll be easy to interact. And I know a magic trick. I know a magic trick, and that magic trick is by looking into your eyes, I can make out whether you understood it or not. No, I mean that's not with me, with every teacher. Okay, when you make eye contact, your confidence will be visible to the person whom you are talking to. So now, in the last class we talked about percentage calculation, and most of you would be knowing. Some of you are new. Yaganya is new, so new in this group. She has been with me for quite some time. But Sammy, you remember Yaganya? She's back in your class. Alright. So here we talk about percentage. And percentage is not math, it is English. Now let's look at why it is English. If I say 70 miles per hour, how do I write it? I say 70 miles per hour. Correct? So this symbol is per. Yeah? Now let's break down percentage. Per and cent. And then age. Forget about the age. Per and cent. What is per? Per is this per. What is cent? Cent is a short form for century. And what is a century? Century is 100. Yeah? So when you say percentage, you are talking about per 100. Now let's see how this English is helping us do math. So I have given a question that, Manas, can you hear me okay? Manas, oh, where did Manas go? Okay, alright. So I'm saying that we are getting a 20% discount in a store. 20% discount, and you picked up something which is priced at $70. So you will get a 20% discount on 70. What is 20% of 70? Now look at the English part of it. 20
percent or century of 70.
You will get a 20% discount on 70, let's say. So you are saying 20% of 70. And this is the discount you will get. Now you look at the thing. And I'm teaching you guys some shortcuts. Okay, if you have zeros at the end, you can do tic-tac-toe here also.
So 1 0 and 1 0 gone. This 0 and this 0 gone.
What I have here now is 2 into 7.
This is the discount I will get. So $14 discount,
Which is 20% of 70 is what I will get. How much I will have to pay?
what was the price? This much. How much discount I am getting? 14. How much I have to pay?
Make sense? Manas is back. Manas went looking for the deal. Okay. Okay. So now let's say, yes, Manas.
Wait, what did you say?
Now I'm saying I was talking about the Thanksgiving deal, and you were not there. So I said Manas went looking for the deals.
Okay, now in the same store,
I picked up something that was cheap, $70, 20% discount. Now let's say Sammy said, no, I will not buy something economical, I'll pick up something costlier. So Sammy picked up
something which is $220.
the sticker price was this much. And the whole store has a discount of 20%. So now Sammy is calculating how much discount I will get, which is 20%. So 20% of 220. Yeah? Find it out. Yes, Jaganya. Can you hear me okay now? So, yeah. So what I was saying was, earlier we picked up something which was priced at $70 and there was a disc. Oh, what happened to Anahita? Halloween costume? Okay. So, picked up something for $70 and we got 20% discount. We paid $56 something. Now, Sammy went to the same store, picked up something which is priced at $220 and she's trying to figure out how much she has to pay. Can you guys calculate it?
Yes, 200.
How much?
200.
What? 20%. 20% is different from 20. See again, same thing, English. Think like English, okay?
20% of this price, that is the discount I will get. 20,
Yes, we had. Vivan, sorry.
About 176.
176. Okay, I'll park that. I'm not telling anybody whether this is right or not. Yes, Yaganya.
I know 176.
You also got 176? Sammy, Anahita, Ashrita, go ahead, beta.
I also got 176.
You guys are becoming good friends. Okay. Let's see what Manas got.
Yeah, I got 176.
So keep one thing in mind. Now let's look at situation like this. So 20% of this,
20% of whatever the price. Do your magic. 10, 10 gone. This 0 gone. What you have? 22 into 4. 22 into 2. $44 discount is what you're getting. So that means 220 was the price and you're getting this much discount. So after discounting this becomes 20, 24, 176. Yes.
this is what you have to pay. Okay. So this is very simple. Now let me. So one word of caution here is,
I know you guys will not make these mistakes, but I'm still saying it as a teacher so that it stays glued in your mind.
when somebody says 100%, it's not 100. Somebody says 70%, it's not 70. 70%. 70 out of 100.
So let's say somebody is priced at $3 and
You are told that there is a 35% discount.
so 35% discount. Now you can relate. You will not get a $35 discount for something at $3 price, right? It's not like you will go and say, okay, I'll pick up a $3 thing, I'll get 35 discount, meaning somebody will give me $32 for buying it. Yeah? It's always 35%. So out of 100, so in 100, you will get 35. In 3, you will get 35 by 100 into 3. 35% of 3. Okay? So anyways, that was just a side note. Now, there is one more situation or one more type of problem that you will come across. Here, if you are given a number and say, okay, find out 20% of this, 30% of this, 40% of this, you can calculate, right? 40% of whatever. Yeah?
Yeah.
Now, let's say, Jaganya, I forgot, how old are you?
11, sir.
You're 11. Let's say, Ashita, how old are you?
I'm 12.
12. Now, Yaganya is 11, Ashita is 12. I'm trying to figure out Yaganya's age is what percentage of Ashita's age? How do I find it out? Yaganya's age is what percentage of Ashita's age? What is 20% of 70? You can unmute yourself and talk to me, Anas. I'm not a bot. You can talk to me. I'm a human being.
Okay, what was the answer for 20% of 70?
I don't know. I will think like English. 20% of 70. So, what a dirty trick that I taught you guys some time ago is when you have zeros at the end, you can knock them off. So this 0 and this 0 you can knock off. This 0 and this 0 you can do tic-tac-toe. What you have? 2 into 7 by 1. 2 into 7 is nothing but 14. That's it. But the word of caution is if you have 104 to be divided by 10, if you do this 0 and this 0 tic-tac-toe, that is not a mistake, that is a crime. Don't do that. You'll only do tic-tac-toe of the zeros which is at the end. Okay? So if you have situation like this, you are trying to divide 140 by 10, then you can cancel these two zeros. It becomes 14 by 1. But if you have 104 by 10, you will not do this. This is strict no. Okay? And all this I am doing or teaching you guys is it will help you do your calculation faster. Think of a situation, okay? You are doing some fancy calculation, but before I do that, Manas, did you get your answer?
Yeah.
Okay.
Yeah, 56.
Okay, so now, whatever you were asking me, did I explain? That is what I was asking. Now let's say you're talking about a calculation like 6080 into 8000 into 500 divided by this into 5000. You can always multiply all these and multiply all these and divide this number by this number. Do you want to do that? No, you don't. You want to simplify it and deal with smaller numbers. Since you see trailing zeros both ways, let's see if we can make them smaller. So 1 0 gone. Okay. Now I have 3 more zeros here. Okay, 1 0 gone. This 0 gone. This 0 gone. Okay, wonderful. Now I have this 0 gone. This 0 gone. What do I have now? I have 6008 into 8 into 5 divided by 50. This is a much simpler calculation to deal with compared to this guy. Correct? We can make it even much simpler because we see a 5 here and a 50 here. Okay. Let's say 6008. I'm not breaking that right now. 8 I can do 4 into 2 and then I have a 5. This 50 I can do 5 into 10 and this 10 can become 5 into 2. So this 5 gone, this 2 and this 2 also gone. What we are left with? 6008 into 4 divided by 5.
Much cuter, easier calculation to deal with, correct? Yeah, Ayush. So Ayush, we have not started learning anything new. We are just catching up on percentage problems and revising those and checking how is everybody comfortable. And again, I'm not rushing to complete anything. I will not leave any topic unless I see each one of you are comfortable with those concepts. Okay? Yes, Manas.
I can't see the board properly. Sorry.
You can't see the board at all, or you can't see the board?
I can see it, but like when it says 6,008 times 4 times, is that a 25?
So let's not worry about that. That was just an example, okay? That was not a calculation part. Whenever we are doing I was just showing you guys how you can use this dirty trick for making your calculation easier or less prone to mistakes. Okay? Alright? Now, so going back to the same question, when I was checking Yaganya's age and Asrita's age, Yaganya told she is 11, Asrita told she is 12. And I'm trying to find out Yaganya's age is what percentage of Asrita's age. How do I do that?
I'm not 11.
You're also 11, but anyways, right now I'm not dealing with your age, I'm dealing with Yaganya and Asrita's age. I'll come to your age a little later, but let's deal with the calculation first.
Okay.
So again, I'm repeating the question. Yaganya is 11 years old, Asrita is 12 years old. We are all trying to find out Yaganya's age is what percentage of Asrita's age. Everybody clear about the question?
Yeah.
How do I do it? Sammy, any thoughts, beta? No? Ivan? Asrita? This is your age, beta. I'm dealing with your age. You have to find it out. Okay. Ayush, any thoughts? Anahita, still dealing with allergies? Yes, beta, tell me.
I think we divide 11 by 12 and then multiply by 100.
And that is the answer. But I have other way of looking at it. Okay? So whatever you said, Araita, that is correct answer. But I'm just breaking it down. If I say, okay, you have 11 and 12, 11 by 12 into 100. You understood it, probably you got it, but not everybody would be able to relate to it. Now I have a magic wand here. Okay? Magic wand is this. When I don't know something, I will give it a name X. Okay? Yeah? Like when Elon Musk's son was born and he was not able to figure out what to give what name to give him, he gave the name X. Elon Musk's one son's name is X, if you guys don't know. Okay? So again, on a serious note, when you're dealing with math, if there's something that you don't know, give it a name X. Okay? X or Y, A or B. Let's say Yaganya is doing it, she will give it a name Y. Sami doing it, she will give it a name S. Bivan doing it, will give it a name V. Okay? Let's give it a name, alphabetical name. Okay? Asrita will give it A. Alright, so we are trying to find.
Yaganya is 11 years old. Yaganya is 11 years old and Asrita is 12 years old. Everybody can see the board, right?
Yeah? Ayush, Manas, everybody?
Yeah.
And we are trying to find out Yaganya's age is what percentage of Asrita's age. Okay? So, since we don't know what percentage, Yaganya's age is what percentage of Asrita's age, let's say it is X percentage. So now my story is this. Yaganya's age is X percentage of Asrita's age. Is that okay? Whatever we don't know, we'll get a name X or Y or A, or Ayush, Asita, Anahita, both will give name A. Okay, minus will give M. So that means Yaganya's age is X% of Asita's age. Okay, so X% of Asita's age. How much is that? 12. Is equal to Yaganya's age. Correct? Yaganya's age is X% of Asita's age. Is this story going well?
Yes, sir.
Since we didn't know what percentage of Asita's age is Yaganya's age, or Yaganya's age is what percent of Asita's age, we said, okay, let's say it is X. So X% of Asita's age equal to 11. How much is X? Meaning, if I want to find out X, that means I want to only keep X on one side, everything else goes to other side. That is how we'll find X, right? We want to come to a situation where we'll say, okay, X equal to what? Meaning, there should not be anything next to X. Right now we have 100, we have 12, everything accompanying X. X wants to be alone on one side of equal to. How do we do that? Across. Meaning, now, whatever you have, when you are making 12 cross the border, okay, it is on the second floor, comes down to the first floor. So 11 by 12. This 12 came down. Now here, whatever is below goes up. This 100 will go here. This is what Anahita was saying. 11 by 12 into 100. How we did it? We said, okay, whatever we have to find out, let's give it a name X. And now we are stitching the story. X% of Asita's age is Yaganya's age. Now look at the story. X. Yep.
91.667.
How much it is?
91.667.
Wonderful. So, anyways, now here everybody will not like one statement of mine, and that is.
Oh no, not that one.
Hold it. Hear me out. There is one statement of mine that none of my kids like.
You don't trust anyone?
What is that?
You don't trust anyone?
There's one more.
Fractions are your best friend?
One more.
Where?
Anahita is saying something.
You play with math?
No. I always say I don't care about the answer. What I care about is how are we doing things. Okay? So if we know the approach, you'll get the right answer as long as you are being careful. If you are very keen on getting the answer, you might not focus on the approach. Here, all this story that I was telling you guys was Jaganya's age, what percentage of Asita's age? Let's say that is X. So X% of Asita's age equal to Jaganya's age. Look at the clarity of the story. If you are very clear with your story, you can convert that to a mathematical calculation. Now, whether it's 96, 98, we can calculate that. Yeah. Now, if you want to calculate, yeah, it becomes 1100 by 12, and this is 12. 9s are 108. Then you have a 20. 12 1s are 12. 8 carry forward. 12. 6 are 72. 8 carry forward. It becomes 91.6666. It continues. Okay? And I'm not trying to flex my calculation speed. I'm just telling you. I mean, you guys can calculate it. No big deal. Okay? Since I forced you guys to memorize tables, I have also memorized tables, and that is what I'm applying here.
Oh. I knew that it's 91/667.
That's what you do rounding. I cannot stop at after 3/6. Okay, this doesn't end. So there's a recurrence here. So when you round it, when it's more than 5, you make this number one bigger, 1.67. Okay, that's okay. That's the rounding part of it. Let's not worry about that because your teacher didn't care about the answers. Yeah, but did you guys understand it? That's the most important part. Everybody? I know why the hand was swinging, but that is also not important. Manas's hand was swinging because of one meme going around. I've heard it so many times. We'll not talk about it. Alright. But yeah. Are you guys clear about what I'm doing? Anahita is also doing the same thing, 2 numbers. Okay. Coming back to this one. But are you guys clear about it?
But was I correct though?
I'm sorry?
Was I correct or was I wrong?
That was correct. I mean, that was correct. What I'm saying is, again, I'm emphasizing that I don't care about the answer meaning. As long as you are doing it right, approach is right, your answer has to be right, okay? Where did Manas go?
I'm here.
Okay, I can see you, but it feels like he's about to punch me.
Okay, now I'm kidding. Now, okay, let's move on. Now, okay, now
Let's look at another situation. One more problem. Let's say my salary is $2,000.
okay, my salary is $2,000.
And Ayush's salary is
$6,000.
Ayush makes more money than I do. Okay?
He makes 4 times as much as you do.
Hold it, don't rush. My question is, my salary is what percentage of Ayush's salary? My salary is $2,000. Ayush's salary is $6,000. My question is, my salary is what percentage of Ayush's salary? Can you guys calculate it?
Sir, can you repeat the question?
My salary, your teacher's salary is $2,000. Ayush's salary is $6,000.
We are trying to find out my salary is what percentage of Ayush's salary.
Okay, sir.
Go for it. Who is the singer in the class? So let's do the song and dance with the problem, okay? Let's see how is the music to the ears.
Sir, can you repeat the question once?
Okay, anybody close to being done?
No, can you repeat the question once?
My salary is $2,000. Ayush's salary is $6,000. We are trying to find out my salary is what percentage of Ayush's salary.
I think I got it.
How much it is?
300%.
Say that again.
300%. 300? I don't think that's...
No. Okay, you find your answer. Let's not challenge others. There's the answer 300%. Okay, let's see what Vivan says. Yeah, Vivan, go ahead.
I don't know if this is correct. I did some random calculations. I got 33.3 with the repeating. 33.3 repeating.
Okay, let's see what Anaita got.
33.333.
Okay, how about Yaganya and Sami?
Same.
Same. Ashrita?
I got the same.
Same. Okay. Sami also got the same?
Yes, sir.
Okay. How about Yaganya?
I'm still doing this.
Okay. Do it.
Yeah, I got 33.3.
Okay.
33.
Okay. Okay, I'm just waiting for Yaganya to complete, then we'll come back to this.
I got 30%.
Okay, 33.3%.
Yeah, 33.3.
Okay, so now going back to the same theory that I was talking about. Sami, you completed your this thing, right? Or you're still working on
I
it?
completed it, sir. I was just going to the restroom.
Okay. So Ayush and everybody. So most of you told 33.33%, and I'm just putting the last nail in the coffin. Okay. So here, my salary is $2,000 per month. Ayush's salary is $6,000 per month, and I'm trying to figure out my salary is what percentage of Ayush's salary. So let's say whatever I don't know, I'll put X. So now I'm stitching my story. My salary is X percent of Ayush's salary. So X percent of Ayush's salary is equal to my salary. Yeah? What is X? I have to keep X on one side, everything else crosses the border. So 2000, now 6000 is above, it comes down, so it comes here. 100 is below, goes up, it's here. Now let's see. This 0, this 0, this 0, this 0, this 0, this 0 gone. What do I have? 2 into 100 by 3. So 2 into 100 by 6. 6 is nothing but 2 into 3. So 2 and 2 gone. 100 by 3. 100 by 3 when you do, you get 33.33333, depending on how much time you have. You can have as many trees. Okay? So this is simple. So basically when you talk about percentage, there are two key things that you will deal with. One is when you have a number given to you and you have to find out X percentage of that. 20% of 500, 5,000, 30% of 5,000, 10% of 500, whatever it is, right? Now, let's look at a practical example. You go and open an account in the bank. Bank says, you know what? I'll give you 5% interest. Same thing. Of your savings account, on your savings account. So if you're keeping $500 in your savings account, they'll give you 5%. So 5% of 500. This is what bank will give you as interest. Okay. So this is, be it a discount, be it interest, be it any other calculation, percentage calculation is going to be an integral part of our lives, okay? Throughout. No matter whether you are studying in middle school, high school, college, you have retired, you are working, doesn't matter. All the time this will be part of our life. So we are not learning this to score 100%, we are learning this to build as a life skill. Okay. I hope you are able to apply it. I'll send you guys some assignment on percentage. Try breaking your head with that. If you are comfortable, I'm comfortable. Alright? Okay?
Wait, we're done already?
I'm sorry?
Wait, we're done already?
No. This was just a recap from the previous class. We learned percentage in the previous class. That is why I wanted to check how comfortable you guys are. And this was Yaganya's first class. So I just wanted to make sure that she's also able to catch up on that. Okay? Alright? Are you clear, beta?
Yes, sir.
Okay. Now let's move on. The next topic that we are going to learn is called exponents. Now, exponents. Let's see who all knows about exponents. We will just touch the concept part of it and see what all we can do with the time that we have today, and we'll continue on this one anyways. Tell me who knows about exponents. Yeah, yes, Sami, go ahead.
Do you want me to say what they are?
Yeah.
So exponents are like a number multiplied by itself. Like for example, 3 to the power of 3. You multiply 3 by itself 3 times. So like 3 times 3 is 9, 9 times 3
27.
is 27.
Okay. Let's see what Anahita says.
I kind of have the same thing as her, except like if 3 to the power of 2 is called 3 squared, and then 3 to the power of 3 is called 3 cubed, and then you call if like you need to do 3 to the power of 5, you do 3 times 3 times 3 times 3 times 3.
Okay. Now, let's see what Bivan and Ashita wants to say. Go ahead, go for it. I mean, no hesitation.
Exponents are basically when you multiply a number by itself, like any number of times.
Okay. All right. Yaganya, similar idea, understanding?
Yeah,
Okay. Okay. Ayush, how about you? Do you know what is exponent?
yes.
Okay. Manas? Manas doesn't want to talk to me.
We haven't learned it, but I know some problems.
Okay. Now, let me break this down in a very simple way. Ashita, good starting point so far, right? Whatever you heard from the friends, that was your understanding too, correct? Yeah. Okay. Now the $1 million question is, I mean, nobody gets $1 million though, but the question is this: why do we need to learn about exponents? How does it help? Yeah.
Exponents help us because instead of trying to like add them all together, like for example, if you need to buy like 3 of the same thing, or wait, that's the wrong example, but
Okay.
you can use it in the real world.
Okay, now look at this. How much time I have to waste? Not only my time, I'm wasting everybody else's time as well.
I'm multiplying 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3. How many times of 3? 2, 4, 6, 7, 9, 11, 13, 14. I can represent this as 3 to the power 14. See how easy it is to represent in this form. If somebody is to count the 3's and represent it correctly, if I miss to count one of this, I might go wrong. So this is a shorter form of representation, okay? That's it. It gives you a way to represent things in a easier, shorter way. Let's say your ink gets very costly tomorrow, okay? And you have to write 335 times. Okay, let's say people start applying huge tariff, 5,000% tariff on ink. Let's say I'm just making it up. So your ink becomes very costly, and you have to write 3 to 335 times. How much space you are using, how much ink you are using, and there's always a risk of making 1 3 and going wrong. See how less space it took. So exponent, as you guys rightly said, is a way to represent a situation when you are multiplying a number with itself. Okay, that is exponent. So here, let's say if I'm talking about 3 into 3, I'm multiplying 3 by itself. And since I'm multiplying 2 3s, so it can be represented as 3 power 2. If I'm multiplying, let's say 4 with itself 3 times, 4 into 4 into 4, I don't have to write it that way. I can write it 4 to the power 3. Imagine I'm multiplying 7 into 7 into 7 into 7 into 7 into 7 6 times. I can represent that as 7 to the power 6. So this is called the base, and the power that you have here is called the exponent. So this is the exponent form of representing a situation when you are multiplying a number by itself x number of times. Is that okay? Starting point? Everybody okay? So basically what's happening is, if I have written 4 3 times, it's only with multiplication, okay? No addition, subtraction, only with multiplication. When I'm multiplying 3 times, I'm putting a power 3. When I'm multiplying a number by itself 2 times, I'm keeping this as a base, and how many times is my power? This is 3, 14 times, so 3 is my base, and I'm multiplying 3 by itself 14 times. That's how I'm representing it. Now let's look at one of the rules of exponent, and we will decode that. Let's say if I'm multiplying 3 to the power 3 with 3 to the power 5, how much that would be?
Wait, give me a second. 3 to the power 3, which is 27.
Okay, let me clarify it. I'm saying give me the answer in the exponent form only, because you have only 10 seconds.
Okay, that.
Okay, so that was just a clue. Okay, now here, look at this. This will be equal to 3 to the power 8. And why I'm saying so, let's look at it first. I have 3 into 3 into 3 to the power 3, okay? That means 3 into 3 into 3, okay? Everybody okay? Yaganya, Ayush, Manas, everybody?
Yeah.
Bivan, Asita, okay? So I've written 3 to the power 3 here. And then I have 3 to the power 5. So that is 3 into 3 into 3 into 3 into 3. So this one is representing this part, and this one is representing this part, okay?
Yes, sir. I think I got the answer.
Don't rush. I don't care about the answer, I told you. Let's not rush.
Okay.
So here, 3 to the power 3 is this, and 3 to the power 5 is this. Now look at how many 3's I have. 1, 2, 3, 4, 5, 6, 7, 8. That is 3 to the power 8. So the essence of this is, when you are multiplying two exponents with the same base, your power gets added. Did you guys see it? 3 to the power 3, 3 into 3 into 3, 3 to the power 5, 5 times 3. So when you look at this, you have 8 3's being multiplied with itself, correct? So what did happen? We had two numbers, two exponents with the same base. When you multiply them, your power gets added. 3 plus 5 became 8. Is it making sense? No? Not yet? Let's look at one more example. 5 to the power 2 into 5 to the power 4. Look at it. 5 to the power 2 is 5 into 5. And then we have 5 to the power 4. That is 5 into 5 into 5 into 5, 4 times. How many 5s do we see here? 6 5s. Yeah? Sami, Ayush, Yaganya, Ashrita, Ivan. Do you guys see 6 5s here? So this can be written as 5 to the power 6. The takeaway is, when you see what happened, this became 5 to the power 2 plus 4, 6.
Sure.
Yep.
So once in my math class, like in my actual school math class, I tried to do it in a different way where I went like this, where I multiplied 3 of them at the same time. Like I tried multiplying 3 of them at the same time. Right? Or
Yeah.
like I don't remember how I did it. Like I multiplied 2, I went 25, right? Because 5 times 5 is 25, and then I multiplied the other 5 times 5, and then I multiplied them together. Is that right or wrong?
No, multiplying that is fine. That gives you absolute value. It might turn out to be a big number. But here what we're trying to learn is, we're trying to learn the first rule of exponent, which says that if you're multiplying two exponents with the same base, your power gets added.
Okay, sir.
So here, 5 to the power 2 is 5 into 5, and 5 to the 4 is 5 into 5 into 5 into 5. What happened? You have 6 5s, that is 5 to the power 6. So the first rule of exponent from this, what we are seeing is, when you have two exponents getting multiplied, the power gets added.
Okay, sir.
Is it making sense, Ashrita, Yaganya, Vivan? Yeah? Now, so if somebody says 2 to the power 15 into 2 to the power 17, you will not stress out. You will not try calculating it this much time. You will say, I have same base, my power will get added. So this becomes 2 to the power 15 plus 17. That's it. That is 2 to the power 32. Then leave. Minus, does it make sense? Ayush?
Yeah.
Okay. Vivan? Okay. Now, let me add some more spice to it, right? You guys all like spicy food or you don't?
Yes, sir.
Like? Okay. So let me add some spice in the math also. Now,
But I feel like sour food.
okay, so I will not add anything sour into it. Okay, let's stick to math. We have only a few more minutes to go. So, if I have 4 to the power 5 into 4 to the power 6 into 4 to the power 9, what will happen? We just saw a situation when we had two exponents to be multiplied with the same base, we added the power. Now we have 3.
So technically what we have to do is we have to add 5 plus 6 plus 9, which gives us 20. So technically it's 4 to the power of 20.
And you are spot on. That is the convention. That's what I was checking. You can check it. 2 to the power 2 into 2 to the power 1 into 2 to the power 3. What does it mean? 2 to the power 2 is 2 into 2. And then you have 2 to the power 1, that is 2. And then you have 2 to the power 3, that is 2 into 2 into 2. How many 2's you see? 6. That is 2 to the power 2 plus 1 plus 3. This is a convention that you can follow for the rest of your life. Meaning, if you are talking about, if you ever come across a problem like this, which says 7 to the power 9 into 7 to the power 6 into 7 to the power 15 into 7 to the power 19 into 7 to the power 3, you will say, I don't care. First thing I will check is, okay, all the exponents have the same base. That means my powers will get added. 9 plus 6 plus 15. 9 plus 6 plus 15 plus 19 plus 3. As long as you write it clearly within the brackets.
Power of 52.
I'm sorry?
7 to the power of 52.
Is that 22, 37, 50, 43, 52. Yeah, 7 to the power 52. Yeah?
Yeah.
Okay, so whether 7 to the power 52 or 51, I would not be worried about it. But my message to you all is that if you are dealing with exponents, same base and multiplying them, the power gets added. Is that clear to everybody?
Now, we have 5 more minutes and I want to honk you guys because tomorrow is Halloween.
Yay!
I want to scare you guys now, right now. So we saw when you're multiplying what happens.
If I am talking about 8 to the power 6 divided by 8 to the power 4, what will be the...
How would you go about it?
Wait, let me see. Wait, so what do we have to do? Oh.
8 to the power 6 divided by 8 to the power 4. So far we were multiplying and we were happily adding the power. Now we are dividing. Dang it. Okay, Anahita, tell me.
So we do 6 to the power 4?
6 to the power 4? No, it's 8 to the power 6 divided by 8 to the power 4.
Oh, I think I heard it wrong.
Okay. So my question to you guys is, so far we have seen when you are multiplying exponents, what happens? Where did Vivan go? Disappeared? I can only see his chair.
Oh, I'm here.
No, Vivan, not you. How about Ashrita? Are you there, beta? Ashrita and Sami are there? Okay.
Yeah.
So Vivan is in disappearing mode. Okay. So
I got, give me a sec.
the question is 8 to the power 6 divided by 8 to the power 4. So far we were doing multiplication and we knew we had to add power. What happens in this case?
So we have to divide it or subtract it?
I don't know. Think about it. I want you guys to think. Because your teacher doesn't know anything. What to do?
So 8 to 4, so 8 to 4 is 128, and 192, 192. So
Oh, okay. Manas, you're going way too far. Don't spend energy when you don't need to spend energy, okay? Energy is precious. Okay, let me show you guys what I'm trying to get you guys guided towards.
Oh,
8 to the power 6 divided by 8 to the power 4. This is not math, this is fun. Let's do fun.
8 to the power 6, that means 8 into 8 into 8 into 8 into 8 into 8, 6 times. Divided by 8 to the power 4, that means 8 into 8 into 8 into 8, 4 times. Time to play. This 8, tic-tac-toe. This 8, tic-tac-toe. This 8, tic-tac-toe. This 8, tic-tac-toe. What are we left with? 8 into 8. That is nothing but 8 to the power 2.
oh,
6 minus 4. No, 8 to the power 2 is not 16. It is 8 into 8, 64.
Oh, my bad.
Yeah. So here, what is the observation we are making here? When you have two exponents, you have to divide one exponent by another exponent with the same base, your power gets subtracted. So your numerator's power minus denominator's power is what you will do. So it's simple. When you are multiplying exponents with the same base, your power gets added. When you are dividing one exponent with another exponent with the same base, your power gets subtracted. And we'll muddle the water more in the next class. We will also learn something called, people say 5 to the power 0 is equal to 1.
What?
Yeah?
It's 0.
Now,
Wait, what?
0 to the power 0 is 0, okay? But any number other than 0
to the power 0 is 1. And I'm not talking in thin air, I can prove it.
I know why it's there.
Okay.
I think I might know why.
Okay.
I thought.
We'll talk about that in the next class. Let's not overstress ourselves. I still want you guys to enjoy each and every math that we do. Yes, Anahita.
Wait, sir, if 8 to the power 6 divided by 8 to the power 4 is 8 to the power 2, then does it also work with like 8 to the power 7 divided by 8 to the power 3 is 8 to the power 4?
100%. That's your rule. Like we saw in case of multiplication, your power. If you are talking about 3 to the power 7 into 3 to the power 5, you are saying, okay, multiplying, so that is adding. The power is getting added. So here, whatever we saw, this becomes a rule for us, which says when you are dividing one exponent by another exponent, you subtract the power of the numerator, subtract the power of the denominator from the power of the numerator. Okay? That becomes a rule. If you, I'm sorry?
What if it's like 8 to the power 4 divided by 8 to the power 3?
Same thing.
No, 8 to the power 3 divided by 4.
Same thing. My basics don't change. It becomes 8 to the power 3 minus 4. How much is that? 8 to the power minus 1.
As simple as that.
Oh.
Our basics will not change. Remember one thing. That is the reason why I kept on bothering everybody to memorize tables. Because tables are the basics. That will not change in our lifetime. Same way here. If this is a rule, becomes something written in stone. Now, how we interpret this, that's what we will learn anyways. Okay? Are you guys clear about what we did so far?
Yes, sir.
Have fun then. Happy Halloween, everybody. Talk to you guys in the next class.
Bye, sir.
Bye-bye. Bye-bye. Bye-bye.